Good morning, my YouTube viewers. It is Crystal here. I wanted to make you another video. In this video, I've created a CSV file for men and women's ages. And then when you get the CSV file for the men and women's ages, then you can perform a hypothesis test on that. So, in order to do the CSV file, we're going to do it in Python, and we're going to use Google Colab to do it. So what we're going to do is we're going to use all of Python's inbuilt modules, so you won't need to import any libraries to do this. So we're going to import CSV, we're going to import random, and we're going to import statistics, SST. So the first thing we're going to do is we're going to make a function to generate random numbers for men and women within a specified range. So the random numbers are going to be, we're going to have num entries, and then the minimum age is 22, and then the maximum age is 35, and the ages are going to be random.randint, min age, max age, for underscore and range num entries, and then we're going to return the ages. So we're going to define the variable of num entries, and we're going to initialize it at 100, and then we're going to generate the ages. So ages men equals generate ages num entry, and ages women equals generate ages num entries. And then now we're going to create our CSV file in Python with open ages underscore data.csv, mode equals W, that's our write, and then new line equals space as file. Writer equals csv.writer file, writer.write row, age men, age women, for I and range num entries, writer.write row, ages men I, ages women I. And then so they're going to do that 100 times because that's the what we initialize the num entries variable to be. And then so we're going to print CSV file ages data.csv created successfully. And then I just wanted to print the mean of the women's ages and the mean of the men's ages. So the women's ages were 28.61 and the men's ages were 29.1. And one thing that I found was that all the means are very close together. So now what we're going to do is we're going to perform a one sample t-test. And of men and women's ages. And I'm still trying to figure this out, figure out the best t-test to do. But I did a one sample t-test. So HO, women's ages are less than men's. And HA, that's your alternate hypothesis, women's ages are greater than or equal to men's. So we see here that the mean women's ages is 28.61 and the mean men's age is 29.1. So we know that the women's ages are less than men already. So we're going to load the data, df equals pd.readcsv, ages data.csv, and then we're going to print the data set. So you can see down here we printed the data set where we've got 100 rows of age men and age women. N equals len of df, so that's going to be 100. Men mean equals np mean df age men. Women mean equals np dot mean df age women. So we're going to print the mean of the men and the mean of the women, which we have already shown you that earlier in this video. Now we're going to calculate the standard error. So standard error equals NP dot square root women men over N and men mean over N. And it says here it says NP square root. So it says that you had to use NumPy to do that. We'll see, because I've got this this script. Let's just see if it says NumPy. Yeah, we have input NumPy's Panda and SciPy. I just wanted to make sure that we had input NumPy, Pandas, and SciPy, which we have. And NumPy is your numeric library. Pandas is your data processing library, and SciPy is the library that gives you your scientific computations. And then so we print our standard error. So if you want to see the standard error, it's 0.75. Now we calculate the degree of freedom. So the degree of freedom is going to be, you've got two columns of data, so you've got two arrays, but they're both 100. So I just said n plus n minus 2. But in order to be precise, you would calculate the length of the men's as being 100, and then you would calculate the length of the women's as being 100. So that would give you a 200 total, and then you subtract 2 from that. So that's going to be 198, and that's your degree of freedom. And there's other ways that you can calculate your degree of freedom, but this is just an easy way that I found on Google. So I decided to do it the easy way. And the reason why is because I want to be able to transfer these programs into Excel, so I have to do it the easy way, because Excel is not as complex as Python. Now we calculate our critical t-value for a 95% confidence level. It's going to be a one-tailed test. Your alpha, or your significance level, is 0.05. Critical t equals stats.t.ppf, and it's 1 minus alpha, and then degree of freedom. So that's going to give you your critical t-value. So we look over here, we find our critical t-value is 1.65. And then we're going to perform a one-tailed t-test. T-stat, p-value equals stats.t-test. IND means independent. DF age men, comma, DF age, DF age women, comma, DF age men. Alternate equals less. And then so we print our t-statistic, and then we print our p-value. So we come over here, and t-statistic is neg 0.86, and our p-value is 0.1932. So so now we interpret the results based on the t-statistic. If the t-statistic is less than the critical t, then you're going to accept the null hypothesis. Otherwise, you're going to reject the null hypothesis. And then if the p-value is greater than 0.05, you're going to accept the null hypothesis. Otherwise, you're going to reject the null hypothesis. So we come over here to our readings. See your t-statistic. That's going to be the absolute value, I think. I think it's going to be the absolute value. Yeah, the absolute value of your t-statistic is less than your critical t. So the absolute value of t-statistic is 0.86, which is less than 1.65. So that means the null hypothesis should be accepted. And then the p-value is 0.19, which is greater than 0.05, which means the null hypothesis should be accepted. So you can see that both of these instances, the null hypothesis should be accepted. And then this is the diagram that has been created using Matplotlib to do that. Whereas I don't totally understand it. It looks to me like you have a really large rejection region, and your T statistic is neg 0.87, and your T critical is 1.65. So, I'm just thinking I'm going to try something here. I'm going to, and it looks like there's problems with my Google Colab as well, but we'll try this out and see what happens. Okay, it's taking just a little bit while for it to work. What I'm going to do is just to try to get it to work, I'm going to run all and see what happens. It's just being a little bit awkward. It says unable to connect to runtime. Okay, so basically what I have done is I was trying to do something on my phone at the same time that I'm doing something on my computer, and I don't have enough computing power to do that, unfortunately. But what I wanted to do was I wanted to swap the men's ages and the women's ages around to see if that affects the distribution. But unfortunately, I can't do that right now because I don't have the computing power to do it. But what you can do, this is what I was going to try. I was going to make the age men and age women, swap them around, which I've already done, and then see if that affected my T statistic, and then see if the T statistic was less than T critical. And so you can see I've already got it. It's just too much for my computer. I need to have like broadband or something like that so I can do lots with lots, but unfortunately I can't do that because I haven't got the money really. So I'm going to go ahead and close this video because I've said everything that I wanted to say, and I created a data set of men's and women's ages using Python, and then in addition to that I ran a hypothesis test, and then it says that the null hypothesis is accepted, but it doesn't it's not saying that on the chart, which I wanted to change the values of the men and women on the formula to see if it changes that on the chart. And you can see now, because I have a lack of memory, my computer program has actually gone off the screen. So having said that, just not to belabor the point, I'm going to go ahead and close this video. If you like my video, please like and subscribe, and thank you so much for watching my video. I'm sorry that I don't have enough computing power to do everything that I wanted to do, but you got the general idea of it. So thank you again for watching my video, and I'll be making more videos for you soon in the very near future.